Welcome to Carlton's Math Corner. Today we're going to be solving two-step equations. At this time, please make sure that you are ready to learn. Our target today is I can solve a two-step equation by isolating the variable. Well, here in front of us we have, again, a balancing scale. And on this balancing scale, we have on the right side, we have a total of 14. And on the other side, we actually have 14 as well. But in this case, we have 3 of some number that is the same. And then we also have 8 additional. And so what we're trying to do is figure out 8 plus 3 of the same number is equal to 14. And we're trying to figure out what that missing number is. Now in algebra, we would probably write it as we would have 3 of some secret number, and I can say that secret number is like p, plus we have 8 more, and that is equal to 14. And this is what it would look like as an algebraic equation. And so our job, first of all, is we're trying to figure out what these pawns represent, what these missing variables represent. And so what we need to do, first of all, is try to figure out what plus what plus what plus 8 is 14. Well, first of all 3 of these pawns together represent what number? What value would they each or not each of them, but all 3 of them together? Yeah, they would represent 6. Why? How did you get that? Oh, I love it. If you actually take 14 minus the 8 that you already know for sure to be true, you get an answer of 6. And if I take away that 8, now I know that these 3, the total value of them is 6. And so now I can figure out what is each pawn worth. Well, each pawn would have to be 2, because 2 plus 2 plus 2, oops, is 6. And so I know that each one would represent 2. And so the value of, if it was in algebra terms, would be 2. Now what I would like you to look at is, here's the equation that we just did. And I want you to notice what steps, first of all, what step did we do first? And I'm actually showing it in algebra terms. And so here's the first step. And what is going on? Exactly. We're trying to figure out what these 3 pawns, and that's what it looked like, 3 times x, and I know in the last slide I used p, and I can actually change this to p so that it is the same. But 3 times some number is equal to, plus 8 is equal to 14. And what we did first was try to figure out how much each pawn, or all 3 of them, was worth together. And all 3 of them is equal to 6. Now what is step number 2? Yeah, we tried to figure out what each one of the pawns was worth. And so we divided by 3. And so we got an answer of 2. And then step 3, what's going on here? Let's change that to a P. Yeah, we're checking to make sure our solution works. So step 1, in terms of, for step number 1, what are you always going to do? And some of you are saying, well, we're always going to subtract. But is that true? Will there ever be an equation that has maybe a, would you subtract if it actually had 3p minus 8 is equal to 14? Would you actually subtract? No, actually we wouldn't. It always depends on what we see here. If I'm adding 8 on, then I'm trying to remove it. And the only way to remove it is to do the inverse, the opposite. And so the opposite of addition is subtraction. That's why we subtracted 8. If it was originally minus 8, then the inverse of that would be addition. So I'd have to add 8. And so we're always trying to remove that number that kind of stands alone with the variable. You know, it's on the same side as the variable, but it's not right next to the variable. Do you notice the 8 is on the same side? Like if I drew railroad tracks right now, it is on the same side as the P, but it's not right next to it. And so I'm trying to get rid of that so that I can have my variable by itself. Okay, so we add or subtract it first. That is our first step, is always to try to get that single number away, at least the single number that is on the same side as the variable. Then after that, we multiply or divide depending on what we see. Like notice the 3 was next to the variable, so that's times, and the inverse of that is division. And then our third step is always check. We need to check and make sure. And I know this is opposite order than normal, because usually in order of operations, we always have to multiply or divide first, and then we add or subtract. It is opposite when it comes to solving equations. So look at this problem, and let's actually do this one together. If I have x divided by 2 minus 4 is equal to 3. Well, first of all, notice on the left side is where the variable is, and I do have a number that stands alone on that side. It is minus 4. So remember, we're doing the inverse always. We're always doing opposite, 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 opposite. So if I see subtraction of 4, what's the opposite? Addition of 4. Nice job. So if I add 4 on both sides, what happens to this 4, the minus 4 plus 4? Yeah, it kind of cancels itself out. It becomes 0. So if that cancels out to 0, then this is what I have. I have x is divided by 2. That remains is equal to 3 plus 4 is 7. And so what I have now is my step number 2. I need to get rid of this 2. And if I have x divided by 2, I need to do the inverse, the opposite. Well, what's the opposite of division? Multiplication. So I am going to take and I'm going to multiply both sides by 2. And I am going to, so I can keep it balanced, my scale balance. And what happens is the 2's disappear. And so I get an answer of 7 times 2 is 14. Now, I can actually take 14 and I can plug it in and check my answer, because that's step number 3. 14 divided by 2 is 7. 7 minus 4 is 3. Yay, it works. How about this one? We have 10 is equal to 3m minus 5. And so here's my steps that I did. First I added 5 on both sides. And so the 5's cancel each other out. I have 3 times something is 15. And the opposite of times is divide. So divide on both sides by 3. And so I got an answer of 5. And if I check my answer, 10 is equal to 3 times 5 equals 5. Yeah, 3 times 5 is 15. 15 minus 5 is 10. Okay, let's look at this next problem. We have v divided by 3 plus 4 is equal to 10. And I would love for you to just try this one, and then I'll show you how I solved the problem. You may pause this video at this time if you need some more time to work on it. Okay, so this is how I solved it. I subtracted 4 on both sides, and so got rid of the 4 first. And so I have v divided by 3 is equal to 6. In order to get rid of the 3 now, I multiplied 3 on both sides. And so the 3's canceled, so V is equal to 18. And I even checked my answer. 18 divided by 3 plus 4 is 10. And so it did work. Aisha wants to have her birthday party at the movies. It costs $27 for pizza and $8.50 per friend for movie tickets. Since it is Aisha's birthday, she does not need to pay for her ticket. How many friends can Aisha have at her birthday party if she has $78 to spend? Okay, so first of all, let's talk about how much does it cost per friend? Well, $8.50 per friend. Now think about it. If I know that it costs for every single friend $8.50, every friend, what is an easy way to write an expression to show that no matter how many friends I bring, I can quickly figure out the cost of them for their movie tickets? Yeah, if I take, and let's say we say C is for the cost of the movie tickets. Well, if I take $8.50 and I multiply it by cost of the movie tickets, that would actually tell me how much it is total, with my certain number of friends. Because every single ticket is $8.50, $8.50, etc. Plus, there's also the cost of the pizza, and how much is that? $27. And it sounds like it's not per person, it's just a flat fee of $27. And then total cost, weren't we given that information? Yes, we were given a total cost of $78. And the question is, how many friends can she invite? Like, how many of these costs are movie tickets, and we can even just say M for movie tickets. How many of those movie tickets can we actually purchase with the $78? Well, let's figure this out. If we, first of all, get rid of the $27, because no matter what, we have to pay that for pizza. So that is something we're stuck with. If we get rid of that, we have $78 minus $27. So we have a total of $51. And then we know it's $8.50 every single movie ticket, which is every single friend. So if I have $8.50 times so many movie tickets, and we have $51 for that, I can actually divide this and figure out how many friends I can invite. And so if I take 51 divided by $8.50, I find out that, so I take 51 divided by $8.50, and I find out I can bring 6 friends, or I can purchase 6 movie tickets. Okay. At this time, what I would like you to do is to solve these 4 problems for your ticket problems tonight. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again.